Okay, in this video we're going to describe the physiology test chamber that we built and used to determine the minimal volume of air required to keep a mouse alive for up to or more than 6 hours in a sealed capsule, the duration of the flight and anticipated recovery period. It's made out of a quarter inch acrylic, as you can see. The interior dimensions are 5 1/4 by 5 1/4 inches by about 12 inches tall. That gives us about 4 liters of volume to begin with, which was way more than we knew we would need. But we did start at a very large volume and worked up or worked down to smaller volumes. To decrease the volume of the chamber, you can see we just fill it with water, and then we put a center column support to hold the platform in the center. It's made out of ABS piping. And on top of that, we put another piece of acrylic. That's the platform with a little PVC feeding cup filled with, in this case, hydrated gel. But we can also put standard mouse food in there as well. Then that sits in there. The mouse goes inside some bedding made of either torn up rags or the shredded material as you see here. In addition, we also put a CO2 scrubber, which is just a vitamin bottle with holes drilled in it, filled with about 25 to 30 grams of pelleted soda lime. Soda lime is the same material has been used by NASA and is used in rebreathing scuba tank gear and other rebreathing applications where scrubbing CO2 out of the air is required. We just get this material online. Again, it's called soda lime, pretty straightforward stuff. Then of course the mouse goes in there. We seal the top acrylic flange with silicone O-ring lubricant. We got this from a pool supply store, but it's a little bit greasy, but it makes a very, very good seal. Then on top of that, we put the acrylic cover, bolt that down, which I'm not going to do completely here, and we could begin to perform some tests. Now originally we didn't have these purge holes in here, and that was because we started by testing just regular air. Unfortunately, regular air has only 16% oxygen, and we found that even 2 liters of air was barely enough to keep a mouse completely active and healthy and completely unperturbed or undistressed for 4 hours. And we knew we had to go longer than that, otherwise we'd have a very poor chance of recovering the mouse after the flight. So we moved to pure oxygen in the chamber. And to get pure oxygen in here, we seal it up. We have 2 holes, and then we purge the chamber with medical grade oxygen, which is back there in that tank. I believe you can see just off screen. Oxygen, I'm going to have a very strong word of warning, is highly flammable. You should not use this if you don't know how to work with oxygen or any other welding type gases. So it's dangerous in that regard, but it is available in both welding supply stores or, as we're using here, medical grade air, or medical grade oxygen, excuse me. So we purge the chamber for about 2 minutes at 2 liters per minute of oxygen, which should give plenty of time to blow out most of the regular atmospheric air and get pure oxygen into the chamber. So after 2 minutes, then we would turn the oxygen off, put a plug in one end, this is where the air would get exhausted, take the other side out and put in another plug. We didn't have 2 plugs, so this may look complicated. It's not. It's just 2 one-way valves we had lying around that we put back to back so air can't go either direction. It's just a plug. But now we have a fully plugged chamber filled with about 80+% oxygen. We have no way of actually measuring exactly how much oxygen is in there, but after purging with a total of 4 liters of air, in this case about a 1.4 liters of volume, we're pretty sure we're probably in the range of at least 80% pure oxygen, which again, compared to 16% oxygen in normal air, should give a mouse upwards of about 5 times or more the amount of oxygen breathing capacity and survivability. And we'll talk about the experiments we performed with the mice in another video. So that's it. That's our acrylic chamber. Any volume you want. And if you have any questions, feel free to email us on the video. After the video, it's on our website at nearspaceorbust at blogspot.com.